In this example, the first thing that you need to figure out is the balanced chemical equation. Once you have that, then you'll have the molar ratio. In this case, it's 1 to 2. There's 1 mole of copper 2 sulfate needed to react with 2 moles of sodium hydroxide to produce the products. I've also listed the given amounts of masses, and I have calculated the molar masses. So first you are asked to determine the limiting reagent. To do this, you need to figure out the total moles available of each reactant. So we're going to take our mass, divide it by its molar mass, and that gives us the moles. Do that for both. Then you need to find the proportional moles, and you use the molar ratio of 1 to 2 to do that. So you take the moles of copper 2 sulfate divided by 1. You take the moles of NaOH and divide it by 2, because that's the coefficient for each. Now we have these proportional moles. This quantity is less, so the sodium hydroxide is the limiting reagent. It's going to be run out first. I boxed these quantities of total moles available because they'll be used in subsequent steps as necessary, and you don't have to recalculate these. You just have to show that you're using the numbers. So next it asks us to determine the amount of copper 2 sulfate left over once the reaction is done. Well, this is the amount of NaOH that's reacting. We need to figure out how much of the copper 2 sulfate will be needed to react with that quantity of sodium hydroxide. Well, we need to go back to the molar ratio. It's 1 to 2. So for every 2 of these, we only need 1. So we're going to need half the amount of copper 2 sulfate. But the numbers aren't always as nice as 1 to 2. What if you had 5 to 7 or 3 to 6? Well, you're just going to set up your ratio. So this is what we're starting with. That's all going to be used up. It's the limiting reagent. Here's our 1 mole of copper 2 sulfate per 2 moles of NaOH. Moles of NaOH cancel out. So we end up taking this quantity and multiplying it by 1/2. Or you can take this quantity, multiply it by 1, divide by 2. It gives you the same amount. This is the amount of copper 2 sulfate needed. So to find the leftover, this value here was our original amount available. So our leftover is going to be what we started with minus what got used up, which is this amount we just calculated, and the difference between those is the amount of leftover. Then the question also asked us to figure out the moles of calcium hydroxide, or sorry, copper 2 hydroxide produced. So again, here's our limiting reagent. All of this quantity of the sodium hydroxide is used up. To find the amount of the copper 2 hydroxide, again, molar ratio. Now, it just happens as well be 1 to 2, and that always comes from the balanced chemical equation, 2, 1. So just like before, you're going to state your amount of sodium hydroxide, and we're going to apply the molar ratio. 1 mole of copper 2 hydroxide that we produced per 2 moles of NaOH that react, and that's now our quantity produced. It asked us not to state moles, but to state mass. So now you take that amount, you multiply it by the molar mass of the copper 2 hydroxide, and that's your mass. We then apply the amount of significant figures. Go back to the original question. This value, 26.00, has 4 sig figs. This number, 5.70, has 3. Our answer can only be as specific as our least specific measurement. So our final answer has to have 3 sig figs. So when we apply that, there's our final answer, 6.95 grams.